All right, so for this section, we are going to graph the triangle ABC using each set of given points, and we're going to determine if ABC is scalene, isosceles, or equilateral. So in order to remember what those words mean, we're going to remind you. So scalene triangles. Oops, why is it not letting me write? Come on. Triangles have different side lengths for all three sides. Okay, so that's scalene. Isosceles triangles have two equal sides. An equilateral triangles have all three same sides. I'll give you an example of each of these, okay? So for example, a scalene triangle would be something like this triangle, where this side is like 1, this side is 3, and this side is 5. Wait, that doesn't even make sense as a triangle. 1, maybe not 1. Here, let me redo this. Let's draw a triangle that's slightly bigger so you can see it a little bit better. Okay, let's make this a 3, 4, 5 triangle. There you go. 3, 4, 5 are different numbers. This is scalene, okay? When all three numbers are different, this is a scalene triangle. Let's take a look at an isosceles triangle. 3 and 5 and 5. See how there's a pair of matching sides? 5 and 5 are the same, so there's two equal sides. The third one has to be different, so this is an isosceles triangle. And then last but not least, we have an equilateral triangle, which all three sides are the same. And by the way, in an equilateral triangle, all three angles are the same as well. If all three sides are the same, all three angles are the same. For isosceles triangle, you have two same sides, 5 and 5, and so these are going to be equal angles. The last angle is going to be different. Okay, so isosceles triangles have two equal sides and also have two equal angles. And then scalene triangles have different sides for every single side. So you might be able to guess that these are all different angles. So all different sides means all different angles. Two equal sides for isosceles, two equal sides means two equal angles, and equilateral triangles with three equal sides also have three equal angles. Okay, so hopefully that reminds you what a scalene, isosceles, and equilateral triangle are. Now let's get on to graphing. Let's start with number 3. So for number 3, we have our first point, 3, 2. So this is my point A. We have the point 2, 4. This is my point B. Actually, I'm going to write the letter B over here. And then our third point, 1, 2, is over here. All right, so now let's connect all three of these. Okay, and we now have to determine if this is scalene, isosceles, or equilateral. So, to me, I can tell that this is an isosceles triangle, and the reason I can tell that is because take a look at, let me make it bolder, this diagonal and this diagonal line. So these two diagonal lines that I've just made bold. These two diagonal lines have the exact same length. And how do I know that? Well, if you go from, let's say, C to B, you have to go 1 square sideways and 2 squares up. Also, if you go from A to B, you go 1 square sideways and 2 squares up. This triangle can be folded exactly in half along this dotted line, and it would be symmetrical. It's like a mirror image. And these are the ways that I can see that these two side lengths are exactly the same. If I were to fold this triangle along this dotted line that I drew, like literally take the piece of paper and fold it, the lines CB and AB would lie exactly on top of each other, which means they are exactly the same length. So we have two sides that are exactly the same length, and then the third side, AC, that's a different length. So we have an isosceles triangle because we have two sides of the same length and a third side that is different. Okay, so I want you to try number 4 on your own, and then we will see how you did. Don't worry if you get it wrong. It's all part of the learning process. So pause the video here. Okay, so now we're unpaused. Let's try it out on, I guess, together. So we have our first point 3, 1. Second point 3, 4. Third point 0, 1. Okay, so let's take a look at this triangle. So it's a little bit hard to tell how long this diagonal is. We're not going to calculate that right now. It's okay. Let's take a look at this side length. This side length is 3. You can literally just count the boxes. What about this side length? Count the boxes. It is also 3. So we already know that it's not scalene because there's already a pair of matching sides. But we have to ask ourselves, is this an equilateral triangle? Is the third side also 3? Well, if you really want to know, we can do the distance formula between C and B to figure out the distance of this line. Maybe that's not very easy to see. This line. If we want to figure out the distance of this line, we can use the distance formula between points C and B because that's connecting these 2 points. So let's try using the distance formula to see if the distance is 3 or if it's a different number altogether. That way we will know if there's 3 matching sides or just 2 matching sides. So let's bring our distance formula. Okay, and then let's have this be our x1, y1. This will be x2, y2. So x2, 0, minus x1, 3, plus y2, 1, minus y1, 4. It's not letting me write for some reason. So let me zoom in so that it will let me write a little better. Okay. And then simplifying inside the square roots, 0 minus 3, negative 3. 1 minus 4, negative 3. And then negative 3 squared, 9, positive 9. Again, negative 3 squared is positive 9. And then we have the square root of 18. And then let's calculate that, which gives us 4.2426, whatever. Is this the same length? No. We have a 3, a 3, and a 4.26. So now that we've used the distance formula, we can tell that we have 2 equal sides, but not 3, therefore making this an isosceles triangle. Remember, isosceles triangles have 2 equal sides, according to our definition on the bottom. So I'm going to write isosceles. Okay, so it's okay if you didn't need to show the work for that. If you already saw it and you're like, I know that doesn't look like a 3, then that's okay. That's cool too. So I just showed the work just in case some students needed to see the work to confirm that it's an isosceles triangle. Because sometimes some people are more visual and some people like to do the calculations. So I just want to remind you guys, if you literally cannot tell how long the side length is, use the distance formula and literally calculate the distance for every single side. All right? Okay, so I will see you guys in the next video. Let me know if you have any questions. Just call me to your breakout room.